This is Unit 7, Lesson 6, and in this lesson we're going to graph systems of quadratic and linear equations. And I've even included a circle in this so that you can see how that works. So they don't necessarily have to be parabolas and straight lines to be able to find the answer to a system of equations. The basic thing that you need to understand for solving systems of equations is that the solution to a system of equations is where those two graphs intersect. And you can have as much as 4 intersections depending on what equations I give you. We're not going to do these by hand. That's too tedious and time consuming. We're going to go straight to Desmos for these. So I've got 3 examples. We're going to go straight to Desmos. I'm going to give you some time to copy these in your notes. Leave a little space for your answers. Remember, your answers are going to be ordered pairs, the ordered pairs where these graphs intersect each other. So go ahead and pause the video, copy down these 3 examples, leave a little space between, and then we'll get to it on Desmos. Okay, this is Unit 7, Lesson 6, and we're going to talk about graphing systems of quadratic equations and talking about their intersection. You can have as few as no solutions, and you can have as many as 4. So depending on what I give you, there is a whole bunch of different ways that we could have solutions to these equations. So for the first one, it was y equals x squared plus 4x minus 4. And there's that parabola. And mine, on my screen, it's green. For the next one, 2x minus y equals 1. And that's a linear equation in blue there. And so I'm just going to figure out where these graphs intersect. So right here, the intersection between those two is at the ordered pair 1, 1, and the intersection, the second intersection here is at -3, -7. And we're finished with that problem. All we're asked to do here is find where they intersect. So these are very simple as if you can use Desmos. They get complicated if you're trying to graph them by hand, because if you make any mistake at all in your graphing, you're not going to be able to tell where they intersect. So that's why we want to use Desmos for something like this to make it more accurate. Putting in the next one, x plus 5 squared plus y squared, this one's going to be a circle it looks like, equals 26. And we haven't talked about circles yet, but really doesn't matter. Desmos will do it for you, so that makes it nice. So that's a nice circle. If we have time this year, we will do conics. That's one of the things that is not tested, and so depending on how much time we have at the end of the year, it's going to determine whether we have time to do this or not. I've had to kind of cut some things out just to make sure we have enough time to cover the necessities. So if you don't get it here, though, you will see it in pre-calculus. But with Desmos, it makes it very simple. So there's the second one, and that's a linear equation. And so all we have to do is figure out where those two intersect, and these are at decimals. So that's at -7.2, 4.6, and then the second one is at 0, 1. So that, again, had 2 intersections, just like before. And if you think about it, you don't have to write this one down, but let's just suppose that I have, I'm just going to put a random parabola in there. Let's say y equals, let's do x plus 4, whoops, squared, up the 22. And I'm going to make it negative, so it'll go down. And I think I'm going to make this have a plus 10, because I want it to have 4 intersections. So I'm just trying to randomly pick something that has 4, so you can see what that looks like. So it has 4 places where this intersects. See, so we could have as many as 4 answers. Now these are, since I made this one up, these are pretty extreme decimals here. I don't try to do that to you on a test or something, but just so you can see that it is possible for them to have 4. It's possible for them to have 3 intersections. Let's say I did, I'm going to make this plus 5.019. If you see that, it has, well, it looks like it still has 4, but I can't, because I can't get that to work exact. Well, anyway, you see how it is possible too to have 3. If this is tangent to that circle here, and you have 3 right there, it's possible to have 3. You could have 2. You could have no intersection. If I made this, let's say this is a -4. I'm just trying to show you what some different answers are. This has no intersection, because if you look at that, there is no place where that parabola crosses that circle. So it's possible to have no solution all the way up to 4 solutions. When we have a circle and a line, it'll most of the time have 2. It could have 1 if that line is tangent to the circle. So it just depends on what they've got and what they give you, and how the 2 intersect. But the answers for this section is, where do those 2 lines or 2 graphs intersect each other? All right, and then for the last one, y equals x squared and y equals negative x squared plus 2. All right, so looking at this, you've got 2 parabolas, one in blue, one in green, and I'm looking for where those 2 intersect. So this one intersects at 1, 1, and this one intersects at negative 1, 1. And again, if you look at this graph, the scale here, each one of these is going by 2s. We could, if we don't like that, we can always change it so that it's by 1. I prefer that it be by 1s. We could even do that, where at 1, 1, it's real evident right there. So we can make it bigger, smaller, so that we can see what's happening there. So my intersections are at 1, 1 and at negative 1, 1. 2 intersections when you have parabolas going in different directions that intersect each other there. So we had 2 answers for that one. So most of these, again, had 2 answers. I don't know what type of, I think most of them in the section in Delta Math that I gave you are going to have 2 intersections, because I think most of them are parabolas and linear equations. So you could probably expect 2 answers for most of them, but just understand you could have more than that. So there are the answers to those 3, in case you didn't write them down. There they are. Make sure you get those in your notes.